Now in this video we are going to implement graph using adjacency matrix. Now here the first thing that I'm going to do, I'm going to create graph node class. So here I'm just going to create a new file and name it graph node. Now inside this file we are going to declare our graph node class. So the class will be like this: public class graph node. So inside this class we are going to declare two variables. So the first variable will be the name of the node, and the second variable will be the index of the node. So in this case it's going to be like this: public string, I'm going to put it variable name, and public int will be the index of the node. So in this case, in name we are going to say, for example, if the node, in node we have A, B, C, D, and in index we are going to say the index of node. Then inside constructor I'm going to initialize these properties as the way that we are getting from the parameter. So it's going to be like this: graph node. So it will take two parameters. So first one will be the type of string, which will be name, and the second one will be the type of integer, which will be the index. Then inside constructor we are going to initialize these properties that we have declared over here with the one that we are getting from the parameter. So this index will be indexed. Now with this we have finished our graph node class, but in the future when we are implementing traversal or other algorithms, we are going to add extra properties over here. But for now, when we are creating adjacency matrix, these two variables, which are name and index, are enough. So we are going to use this graph node class inside graph class. So here the next thing that I'm going to do, I'm going to create a new file, and I'm going to declare in this file graph class. So it's going to be like this: graph.java. So inside this file I'm going to declare our graph class. So it's going to be like this: public class graph. So here I'm going to use array list, so that's why I'm just going to import array list from Java util library. So it's going to be like this: import java.util.arraylist, because in this case we are going to save the nodes that we have in our graph to the array list, and we are going to save the edges that we have in our graph in the two-dimensional array. So here the first thing that I'm going to do inside this class, I'm going to declare array list, which will take the type of graph node, and in this array list we are going to have the nodes that we have in our graph. So it's going to be like this: array list. So it's going to be type of graph node. So this is the graph node that comes from this class over here. So I'm just going to put graph node, because inside this array we are going to save the nodes that we have in our graph. So that's why I'm going to name it node list. So it's going to be new array list with the type of graph node. So with this we have declared our node list over here. Now the next thing that I'm going to declare, I'm going to declare two-dimensional array. So in this case it's going to be the type of integer, because in this matrix we are going to save the edges of the graph that we have over here. So I'm going to name it adjacency matrix. Now then inside constructor we are going to initialize the node list that we have over here, and we are going to initialize the adjacency matrix. So in this case it's going to be like this: public graph. So this one will take only one parameter, so the parameter over here will be the type of array list with the graph node, because in this case we are just going to get the nodes from the user. So it's going to be array list with the type of nodes over here. So here again we are going to use graph node, and I'm going to name it node list. Then inside constructor we are going to initialize the node list and adjacency matrix. So this node list is equal to node list, and adjacency matrix will be initialized based on the size of this node over here. So if we have 5 nodes in our node list over here, it's going to be a 5 to 5 matrix. If we have 6 nodes, it's going to be 6 to 6 matrix. So that's why in this case it's going to be initialized like this: adjacency matrix is equal to new integer with the size of node list size. So we are going to use the size function over here. So I'm just going to use for the number of columns as well. So it's going to be like this: node list.size. So with this we have successfully initialized our matrix over here. So when we are initializing integer matrix, default values in this case will be 0. So what we are going to do, we are going to create an extra function over here which adds the edge of this node to this matrix over here. So it's going to be like this: I'm going to declare the function in this case like this. So it's going to be public void. So in this case, it's not returning anything. So I'm just going to put add undirected edge. So in this case, we are going to add undirected edge. So in this case, this will take two parameters. So the first parameter will be I, which will be the index of first node, and the second parameter will be the j. So this will be the index of second node. So by adding these indexes over here, we are adding edge between them. So if we add 0 and 1, so we are creating a link between first node to the second node. So in this case, if we are adding an undirected edge, we are going to add edge in both ways. So it's going to be like this: adjacency matrix. First, we are going to use as a first index I, then we are going to use as a second index j. Then in this case, it's going to be like this: 1, because as we said before, if we have a link, we are setting 1, otherwise they are 0. So when we have initialized them, all of them are 0. So in this case, we are going to add both way to this adjacency matrix over here. So then in the next case, I'm going to put first j, then I. In this case, we are creating an edge from I to j and j to I over here. Now with this, we have successfully implemented our method over here. Now what I'm going to do over here is I'm just going to create an extra function over here which prints out adjacency matrix to the console. So in this case, I'm not going to go to the details of this function because this is not the main objective of this lecture. I'm just going to copy and paste the code that I've written before. So whenever we are calling this code over here, it's going to print out adjacency matrix to the console the way that I showed you in our previous lecture. Now this is how our function looks like. So in this case, I have created a function like this, which is printing out adjacency matrix over here. So I'm not going to go to the details of this function. So if you want, you can examine this function to see how it is going. Basically, it's just looping through the node list and adjacency matrix and printing out the values to the console the way that it looks like as a matrix. So what I'm going to do now, I'm just going to head over to main Java class. So in this class, we are going to create the graph that we have explained in our previous lecture. So as you remember, we had a graph like this and we have created this graph using adjacency matrix. So here again, I'm going to implement the same graph in adjacency matrix. So here, the first thing that I'm going to do, I'm going to create array list with the type of graph node, because in this case, I'm going to add the nodes in this node list over here. So I'm going to name it node list. So based on this node list, we are going to create our graph. So it's going to be like this: new array list, like this. Now to be able to use the array list, so here again, you have to import the array list from the Java util library. Now the next thing that I'm going to do, I'm going to insert the nodes that we have in our graph over here to this array list over here. So in this case, we have 5 nodes. So this means that we have to create them one by one add to this node list over here. So it's going to be like this. We are going to use the add function of the node list. So here again, I'm going to put like this graph node. Each time we need to create a node. So as a name, the first node will be A. As an index, so if we have the first node, it's going to be 0 because index starts from 0. So with this, we have added A to this node list over here. So I'm just going to copy this code from here and paste it 4 times over here for other nodes. Then we are going to add the other nodes one by one. So the second node is B. So it's obvious that the index of B will be 1. The third node is C. So the index of third node will be 2. The fourth node is D. And the index of D is 3. And the fifth node is E. And the index of E will be 4. Now with this, we have successfully added all these nodes that we have in our graph to this array list over here. Now based on this node list that we have created, we are going to create graph. So graph will be created based on the graph class that we created over here. So it's going to be graph G new is equal to new graph. So it will take as a parameter node list. So based on this node list, it's going to create our matrix with the size of this node list. Now then we are going to use the method that we have created over here, which is add undirected edge. So in this case, it's adding both ways. So that's why we have called it add undirected edge. So I'm going to use this method to add the edge that we have over here to this graph over here. Now the first edge is from A to B and B to A. So in this case, we know that the index of A is 0. The first index will be 0 and the index of B is 1. So I'm going to put 0 and 1. So with this, we are creating a link from A to B and a link from B to A. Then I'm just going to copy it from here and pass it one more time. So in this case, we are going to continue to the next edge. So the next edge is from A to C. So from C to A. So in this case, the index of C is 2. And the index of A is 0. So I'm going to put 0 and 2. So with this, we are creating an edge from A to C and from C to A. Then we are going to continue to the next edge. So the next edge will be from A to D and from D to A. So the index of A is 0 and the index of D is 3. So I'm just going to put it over here 3. So with this, we are creating an edge from A to D and from D to A. Then we are going to continue to the next edge. So the next edge starts from B. So the first edge is over here from B to A. So you can easily see that we have created over here when we are creating from A to B. And then we are going to continue to the next edge. The next edge is from B to E. So in this case, the index of B is 1 and the index of E is 4. If you put like this, it's going to create a link from B to E and from E to B. Then I'm going to continue to the next edge. So the next edge is from C to D and from D to C. So the index of C is 2 and the index of D is 3. So we are taking it from here. So with this, is creating both way link between them. And at the end, the last edge is from D to E and from E to D. So in this case, from D is 3 and E is 4. So with this, we are creating a link between them. Now then at the end, I'm just going to print out the graph that we created over here by using gToString. So this is the method that we have created at the end over here inside graph class. So with this class, we are printing out the adjacency matrix to the console. Now before printing out, as you remember, we have inserted all these edges in our previous lecture to this adjacency matrix over here. So this means that our adjacency matrix should look like this. So if I run our code, so here the output shows like this. So if you compare this output with this matrix that we have over here, you can easily see that they are identical. So here the ones shows that we have a link between these nodes over here, and 0 shows that we don't have links. So as you can see over here, the diagonal over here is 0, as we mentioned before. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented graph using adjacency matrix. So hopefully everything is clear about this implementation. Now in the next lecture, we are going to implement graph using adjacency list. So see you in the next lecture.